Question: evaluate this guy. We answer this question. So what is this? We review the knowledge. First, for random variable z follows the standard normal distribution. The mean is 0 and the variance is 1. Then we use this notation to represent the probability that z is smaller than the small z. So this is a notation. This notation represents a probability. The probability that the random variable is smaller than the small z. Let's go on. For the random variable x follows normal distribution, the mean, mu, and the variance. We can create a new random variable z. Z equals x random variable x minus its mean over its standard deviation. Then z follows standard normal distribution 0, 1. And we know the probability that x is smaller or equal to small x. This probability equals the probability that z is smaller or equal to small x minus mu over the standard deviation. We know this. If we use the lowercase letter z to represent lowercase x minus mu over the standard deviation. If we use the small z to represent this guy, then this equals the probability that the random variable z is smaller or equal to small z. So if these guys equal to the lowercase letter p is the probability to represent these probabilities. So if this guy, then we can use a new notation. This one is -1. Here is p. This equals the lowercase letter z. So this guy as a whole, it represents a value. So this guy is a value and p is a probability. And to notice, if we use this guy, to replace the lowercase letter z here. So we can get the probability that the random variable z is smaller or equal to this guy. This is a value. So we use this guy to replace the lowercase letter z because they are equal. So then we know this equals to p. Yeah, we just use this guy to represent the lowercase letter z. Then we can get this equation. Now we go back to the question. So the probability that z is equal to or smaller than this guy. So this equals the lowercase letter x. So compare this one to the top one. We just use lowercase letter x to replace the lowercase letter p. So we get this one. And we also get the probability that the random variable z is smaller or equal to here is 1 minus x. This equals 1 minus x. Then from this guy we can get the probability that z is bigger or equal to this guy. This equals 1 minus the probability that z is smaller or equal to this guy. So this is the property of the probability. Then go ahead. We use 1 minus x to replace this guy. Then we get 1 minus bracket 1 minus x. We get this one. Why we can use 1 minus x to replace this guy? Because they are equal. Because from here we know that they are equal. So this one equals locus delta x. So now we know this guy. We know this guy equals locus delta x. And we also know this guy equals locus delta x. Now let's check the graph of the probability density function of the standard normal distribution. The graph is like this. So this graph is symmetric, about 0. Then we know that the probability that z is smaller or equal to negative this one, 1 minus x. This one also equals to x. Compare this guy, and this guy. We can get this guy equals negative this guy. So they are equal. Now we move this guy to the left. We can get this guy plus this guy is 0.